So you confirm you can still hear me, then we can just go.
We can. But you need to be audible, please.
Oh, okay. Thank you. Okay, so my name is Fanin. You can see on my email, Ishen Fanin. And so also a student. I'm your course mate. Yes. So I yesterday I noticed that some persons were having difficulties in joining the class, and that was why. And then I was like, okay, it's something I know, so I can actually do it for people that do not understand, so that we can all be on the same page. I think, and so that is why I said, okay, let's start with tutorial, and then people are like, okay, yeah, it's fine. So we're going to do it together. So this is where the man started. He started from this page. This is introduction to statistics. So you all agree that statistics actually deal with numbers, just like he said, just numbers. So according to him, he says statistic refers to a set of figures of data. Now, if you want to be more like broad or you want to expand it very well, you can actually say that statistics, it has to do with collection of data. Because for you to start working with data, first of all, you have to get the data. You have to collect the data from somewhere and then you start using it. So statistic can also mean as collecting and analyzing and interpreting data. You understand? So it's I basically refer to a set of figures with data, the same thing. So you also talk about statistic is seen as a tool of analysis. Oh, very good. Yeah, this is tool that is seen as a tool of analysis. And statistic is so in this class, it's a tutorial, so you can ask questions. We're actually going to just like anything you don't understand about statistics from what we are talking about now. Yeah, we can just ask the question. Then when I answer you, maybe another person too can get more understanding from the question you ask. So, but then we'll just continue from this man's note. So, statistics is he said also a science. It's a science of data. Is statistic a science or an art? I think he asked this question, and he said that statistics is actually a social science subject, and because it does not really it can be science, but then it's not that scientific because there are some things that just like you said, there are some things when you go to the lab, if I test you for maybe typhoid now in the lab, I will get the result. But in statistics, it is not you can't get the perfect result. By the time we go further, you understand that in statistics deal with numbers, and most times you just make use of a portion of data to just conclude on something. So at the end of the day, that means that data you cannot say something is 100% what correct in statistics. That is why you always give a 0.5 percent error. That one is given. You give 5% error. That's what you can say. If you want to test in statistics, you actually go with a confidence level of 95, so that you give 5% for error. So whatever happens, it takes that. So statistics believe that there must be an error in something. So that's why we give 5% for error. So he talked about the types of statistics, and then there are two types of statistics. So we have the descriptive statistics, and then we have the inferential statistics. That is that. So the descriptive, the first one here, the descriptive statistics, it helps you to summarize data. That is to you have the data that you want to talk about it. You want to know about your data. Help you to summarize it. Help you to just talk about, for instance, now I like giving example, practical example, so that it help you guys to just understand better, right? So let's assume that you you have a particular data set. Let's say you work in Access Bank, and then you want to actually calculate the amount of people of customers you understand that open accounts for the past 6 months. Do you understand? So you have the data of people that open accounts for the past 6 months. So at the end of the day, now when the data, let's say for the past 6 months, we're going to have daily. You can actually do it daily, or you can do month. So let's say for the past 6 months, that means you're going to have in June you have 20 people, in July you have 30 people, in August to have this number. So at the end of the day, we want to know that is the whole total number of people you have. You calculate it from this 6 months you have. You can also do the mean, that is the average. You want to know the average number of customers that can actually come to your bank or that open account in your bank for the past 6 months. So you can know that, okay, you can say that this is the number of people that open account every month because that data was collected for monthly data. So this particular month was this like that. So that is descriptive. You just describe the data. That data is not going anywhere above this level. You understand? So it's from there you can do the median, the mode, and all that. Right? Are we still together? Are we understanding?
We're together.
Okay.
Go ahead.
So like I said, if you have a question, you just ask so that we'll just be on the same page. Uh, so I'm still trying to make you understand what is descriptive statistics. So it talks about the mean, the mode, the median, the chart, all the charts you see the tables and the percentage, all these things are just descriptive statistics. So in short form, what that means is like descriptive statistics tells you what happened to your data. What is happening to your data? That is actually what is going to be known. You understand? And then when you want to do analysis now, when it comes to data analysis, the statistic is actually field of itself. Now, inside the statistic, you have to do data, you have to do analysis. So when you are doing analysis, there are different stages of analysis. You have the descriptive statistics, and then we have the diagnostic statistics. That now you understand, you know why, you know what happened to your data. So you can do a diagnostic analysis to know why did that thing happen. You get now I can do a diagnostic analysis to know why did this thing happen. I can do a prescriptive analysis to take actions. Now that is when you now say, okay, now that I know what happened and I know why it happened, now what actions can I take to avoid this thing or to improve this thing? So after you have done the three of them, you can now do a predictive analysis. That is where you now do a predictive analysis tells you what happened in the future. You get so basically all these things just fall under types. Those ones I just mentioned are just data analysis. But then when you're talking about statistics, you're still talking about data. So so moving on to the next thing, which is the inferential statistics. So this one it goes beyond description. Like it is like when you want to make predictions or you want to make a decision about a particular data set. Now, in this one here, this is more complex and this is more statistics now, right? This is the real statistics because in inferential statistics, you are making a decision with data, and that decision is going to affect, in fact, everybody. Let's just imagine that somebody just sits in Abuja, make a decision about a particular data, and it's going to affect everybody, whether you like it, whether the data is correct or not, it's going to affect you. So, and that data, because for instance, let's just say, okay, they want to do population, like they want to count people in this country. Do you think they are going to count everybody, every household? They can't do that. So what they do in differential statistics, they can now take a sample. Let's just say they want to know the number of people that are out of job, that does not have job in this country. Do you understand? They don't know everybody. They can't count everybody. Even if they say everybody should go and submit application that they don't have it, it's not everybody that will go. So the only thing they can do now, they can only take the data they have. They can just do a simple, instead of that, they can just take a sample data of, so let's just say the whole population now we have 4 million. And then they can just take only, they can even take they can even take 500,000 people to say, okay, now with that 500 people, 500,000 people, they can use it to say, this is the number of people that are out of job. And that's statistics. It's gone. Whether you like it or not, it happened. So that is what this guy knows. That's what the inferential statistic tells us. You understand? So now in this point or in this type of analysis statistics, We can also look at, like, for example, let me give you a practical example, like the one I talk about Access Bank. So let's say you work at Access Bank and you have Access Bank have a sample data of 100,000, like 100 customers. You understand? So this 100 customer, what they want to do with it is like they want to know their satisfaction level. They want to study the customer satisfaction level. Sorry. So what they would do now, they are not going to, let us say, okay, they want to know that in the whole country, the whole country. They want to know the satisfaction level of their customers in the whole country. Now, do you think they are now going to be moving from one state to another? No, they can't do that. They can even decide to just take the satisfaction review from the customers in Lagos alone, right? So they can use that to publish that this is how they are satisfying their customers. Does that mean they count everybody? No. Everybody was not there. All their customers were not. In fact, some customers that they did not even get their feedback are more than the one they collected feedback from. But with 100 or 1,000 of customers that said this and this, they can actually conclude that, okay, this is. So this is a statistics that actually make decisions for you, for everybody. I hope you understand that one so I can move to the next thing. Okay. So now we to talk about the significance of statistics. We're talking about like the significance here, talk about the importance of statistics. Why is statistics important? Why is this guy important to you? Right. So number one point he said for compression. So so this is just like the example we gave from the other end. The compression here means that it helps you to compress a large amount of data into simple summaries. For instance, I have 10,000 uh, as let me see your Access Bank as a case study. I have Access Bank, or let's say UBA Bank. They have about 110,000 daily transactions. You understand? So instead of them to know, you understand? So what they can do is like they can summarize this data in average to know the transaction size. So by the time they have now they have a daily transaction worth, we have 10,000 transactions in a day. 10,000 in a day. So if I want to analyze this, I can actually go ahead to say, okay, I can just take the mean of my daily transactions and it's fine. I'll go with it. It's fine. That is very 100% correct. So instead of me to sit down and be counting the number of transactions like that, I can just add everything and then divide it by that 10,000 and I get the average of transactions and I'm good for that day. So I can say that this is the average number of transactions we have in a day. So it has compressed. You can see statistics are able to compress the whole data. That large volume of data have been reduced to just an average, and you are good, 100%. So we also have evaluation. Yeah, now the evaluation help here it helps you to measure the performance and compare results. You understand? It helps you to measure a performance of an event. It can be a project. It can be a project. It can be an event. It can be a product. It can be a service. So what it's doing is like I can evaluate my own product. I know that okay, yeah, this product is adding value or it's not adding value. When I evaluate it, I look at how is it performing in the market. So do I need to remove some things from the product? So that is statistics. It's helping you to do that. So it helps you to evaluate a product. It can be an event, like I said, it can be an event, can be a project, whatever at all. So another one we have the forecasting. So this is best. This one here, it helps you to predict the future outcomes. So this can help me to know what is going to happen even in the next 20 years. Do you get? So that's why they can project, they can actually predict the future for you to say, okay, Nigeria will be out of poverty in the next 20, in the next 5 years. Now, how are they doing that? Now, for you to project, that means you have to have the current data. So it is when you look at the trend, or you look at, now when this goes more, there are a lot of method that can use for forecasting. You understand? There's a statistical method called time series. There's a statistical method that's called time series analysis, and then it helps you to understand all the method that you can use to forecast for the future. So all this, once you have the data in that manner, you're able to predict it. And also the simple way of predicting data is use of regression model. It's very simple. I think it's all in fact it's part of this class, but I think it's down. But I guess it's still there because I've gone through the material and I've seen that. So this basically helps you to to know what is happening in the next year. And then we have estimation. I think some person were like asking, what's the difference between evaluation and estimation? Right? So now estimation is used to estimate unknown parameters. Now, what is unknown parameters? They are just like you have now parameters in analysis. Just like I said, in the inferential statistics, when maybe you don't want to go to focus on the full population, so you go with the sample. Do you understand? And sometimes this sample, these particular parameters that you are going to use in that your sample, they are not known. It is when you want to do they are not known yet. Those things are not known. Because I don't know what is going to affect this guy. I don't know what is going to affect my decision in forecasting yet. And let's say I want to forecast for an event, but I don't even know the parameters I'm going to use from here. So, but now what this statistic do for you? It will help you to estimate it. It's just like I can just assume. You understand? I'm going to assume a particular value. Let's say x is equals to this and that. So you can estimate them and just keep them so that you can use them to do your forecasting later. So for example, let's assume you want to estimate the average income of Zenith Bank customers based on the sample. Do you understand? You want to estimate the average income. You understand? So what does that mean? You can use statistics to do that with data you have. So with the data, the current data of their staff or their customers that I have, I can actually know how much. For instance, now if I go to the Zenith Bank, I know their customer, I know how much is in their account. I can actually know what they are making every month based on how much is in the account. So I can use the data that is in the account. I'll use that to estimate that okay, this particular customer should be earning like what is his monthly income should be like 20K or 200K based on the activity that are going on his card. Do you understand? So I just take the sample from the bank and use. So we also have the last one here is talk about the test of hypothesis. Now, hypotheses are just like guess. You understand? They are just like guess that can be proven. For instance, I can tell you that the number of people in this class, right? The number of people in this class, everybody here is 25 years old. And then another person will say no. Now, these are guess that can be proven because if I say everybody's 25 years old, you said, maybe another person said, no, it's not everybody that's 25 years. So we now have to test. So the first hypothesis, the no hypothesis was me saying that everybody's age is 25. The alternative hypothesis is you saying that it's not everybody's 25. So we are going to test it. So we can choose a particular statistic method or, or we can choose a statistical method to test. So by the time we test, we can either reject my own, accept your own. So that is what the method is talking about hypothesis. So we test on certain, like you can use different statistical tools like we have the ANOVAs, we have the chi-square, all those ones. So when we use that, we can now test it, and then you can now say that okay, based on we can make a decision based on the confidence level, the confidence level and the p-value and then the alpha value. So these are the values that can be used to test and accept or reject a hypothesis. So, did you guys understand the points I made on this?
Yes, please.
Okay. Okay. So the
Yes,
last.
we do.
Okay. So the next thing he said was limitations of statistics. Now we look at the importance of statistics. Now, what are the disadvantages of statistics? It has some limitations because they said that this one said the statistic of the study of qualitative phenomena. So what is basically telling you that statistic does not deal with uh, emotions, right? It don't deal with emotion, it don't deal with loyalty or motivation. It just care what scientists care about is data, something that we can measure, right? So it does not deal with emotions at all. So even if let's just say, okay, uh, imagine I'm in the office with my boss and sir, I'm not feeling fine, right? They will be like, go and bring your your medical report. Now I want to see the data. My boss want to see from the hospital that I'm not fine. But then if I just tell him that I'm not feeling fine, he just feel like, no, this guy, you are lying. I want to see proof that you're actually not feeling. That is actually what statistics does. It does focus on the data. So whatever you are saying, that's why you can say everybody will be poor, everybody is dying of poverty. But statistics can say that nobody is in poverty and it does not care. So once what the data is telling you is what whatever it's in the data, that is what statistics is going to use to make decisions for you. So that is actually what that means. Okay. So we have another level, which is another one, which is in statistics deals with individuality. So it does not deal with individuality. Yeah, individuality means that it does not deal with them. So it statistics deals with groups, not individuals. Did you understand that, or I should explain with example?
Yes, I should.
Okay. So what I mean is like individuality here means like statistic does not it deals with groups, not individuals. So for example, uh, taking an example that is not common. Uh, which example? Okay, so let's assume like what example am I trying to say? So okay, let's look at an average salary. So let's say that if you want to look at the average salary in a branch, you understand, like in a branch, let's say bank, like a particular branch in a bank. So the average salary in a branch may hide some extreme figures. Understand? Like for instance, a manager is earning like 1.2 million, right? And then the cashier is earning like 150K. Now, why what does that mean to you? Now, what happened here is that if you are looking at that now, what is happening in that sector is this: the person that is a cashier, the moment that cashier becomes a manager, he's going to earn that amount of money, right? So even though that person that is earning 150K as a cashier, if the person decide to be manager today, so they are not going to. It's not really about like the much work you are doing or whatever. It's a group. Now there's a group of people that has this particular benefit. So whoever, so it is not like I'm going to say, okay, I'll pity this guy because he's doing so much work. So let me say, okay, because you are doing so much work, let me be paying you 500K. No, as long as you're a junior staff, that salary is yours. So it is the group that they are focusing on. So the cashier is a cashier. Whoever is a cashier, your salary is 150K. Whoever is a man, their salary is that. I don't know whether that example actually give you idea of what I'm trying to say.
Yes.
Okay. So this one, the third one here, it's basically talking about when you're talking when you are dealing with statistics, is most times, especially statistics and mathematics, there is what is called approximation. You can approximate values. So when you approximate values, it is not actually giving you the exact truth. The truth is not actually there. You understand? So I can actually have something like uh two 3 point something, and then I can approximate to give me a full figure. But like a good example I can give to you, like let's just assume that we want to get feedback the from our customers, right? We want to know how they are satisfied with our product. Let's say I'm selling a particular product, and then I get feedback from the customers, and I'm having 85%. Understand? I'm having 85% people saying that they are okay with the product, but that does not mean every customer is happy. Do you understand now? It's not that every customer is happy, but having 85%, I can even have 95% of customers saying they're happy, but it's not everybody. But that is, do you understand? But that is very high. But it's not everybody that's saying that actually. So what is there like? I'm going to make just say that okay, my customers are happy with me because but one customer there is angry about that particular product. So it's not giving you the actual truth. It's just going to approximate value and just give us summarize something and say, okay, yeah, this is what's going on. But that does not mean that is what is there. So that is why there are limitations. There are just kind of disadvantages. And also misuse of records. Now, this one here has to do with the the person that is doing the analysis. So the misuse of record here handles it talks about wrong data collection or interpretations. You understand? Because when you get the data that is not correct, and you are maybe your interpretation is also not correct, it is going to lead you to false conclusions. You understand? It's going to give you wrong result. So you're going to make decision that is not actually good. It is not correct because your data is not correct. You are having the wrong data set. So misuse of record. So you did not use that data as it's where it should. So it's going to give you wrong answer at the end of the day. And if you're going to make decision with that data, it's going to affect someone, and it's not because the person that is going to affect me not even know, but the person that did the work is the one that is guilty. So that person will go to jail. Just send it to jail to go and stay there for like 2 years. Then you come back. So okay, so I think okay, it was not even plenty. So he talks about again. They talk about sources of statistic data, right? So we talk about the primary data source and then the secondary data source. Now, when you are talking about primary data source, this is a data source that it applied or used, or when the data you are using for your project or for your analysis is gotten at first hand. First hand means like you are the one getting that data. For instance, I want to do the impact. I want to know the impact of paracetamol on pregnant women. Right now, let's say I go to the hospital, and then I go to the hospital in the antenatal ward to be like, okay, I'll meet all the pregnant women there and I give them some questionnaires to be like, ma, please just, I'll ask them some questions and they're going to feel how. So from the way they're going to answer the questions, I will know how the paracetamol affect them. Do you understand? So I'm collecting the data at first, and so I am collecting it, and that method of collection is called primary data source. Now we have another data source which is called the secondary data source. So this is a data source where uh, the data is being collected before. You understand? The data has been collected by someone else or by an agency, and it's being so what they are giving to you is a kind of a report. It's a process report already. So just like I want to do analysis on or maybe COVID-19, COVID. Now COVID has passed, but now there's a data somewhere about COVID, right? There's a data, so I can go to like and HW and WHO now to give me some data about COVID-19. Now that data source is a primary, is a secondary data source. And whatever they give me, that's what I'm going to use. So because I'm not going to come and change anything on it. So and this one has a limitation because the person giving the data may not actually be correct, but then you have to use it because that is what they're giving you. Unless you want to analyze some data about accident that happened in Lagos from 2021 to date. Where do you think you're going to get that data? You don't know the people that even had the accident. So you cannot go and be meeting them now to collect data. So you have to go to the road safety and then tell them that I need to know. I'm doing a project about the case of accident that happened in Lagos between 2021. So they'll just go to their database, give you the data, and you come back and use the data. And so that is the secondary data source. So, like I said, the primary data source can be gotten from questionnaires, interviews. You can actually interview someone to get feedback from them, or you can send questionnaires to get feedback. So these are basically the things that the man discusses today. Thank you for this as
Thank you very much.
well. Yes.
Thank you so much.
Thank you.
Yeah.
I really appreciate.
Yeah.
Yeah, we enjoyed the class as well.
Thank you so much. Thank you.
Okay. So yeah.
Keep
So yeah. Okay. So a quick one. So we I don't know because that means we'll be having our tutorials after the mass lecture, right? So that we can be having the lecture or tutorial when maybe authors or we want us to be ahead of or some terms. Though me, I've gone through the material
After
already.
his lecture is better.
You what?
After
To
his
be
lecture
ahead of.
is better.
I
Okay,
think after the
Okay.
lecture will be
yes,
better
after the
because
lecture. Okay,
it's
fine.
going to be like yes,
Yes, okay,
like a revision
okay, perfect. So after his
session.
lecture,
Yes.
and then we now have our tutorial. So let's assume, let's say he's having we are still going to meet next week, Tuesday, then we have our tutorial on Wednesday. Then that will be fine. So
Yes, please.
and then some days we just join them, we just do some question papers. I have some past question papers that we can just solve from the school. I have some of the question papers that I've done. So maybe we can just uh,
Oh,
solve them together. Maybe just solve them.
thank you very much.
Yeah. So that's all for today. Except you have something to say. If not, then we can just close.
Mm. Do you have a recorded version of this tutorial?
Yes, I have.
For some people.